This project can measure the RPM of a DC hobby motor. The circuit can be broken down into three main parts: the motor control portion, which features a potentiometer and two cascading NPN transistors; the sensing portion, which features an IR brake beam setup and a comparator; and the display portion, which features an OLED display to show the calculated RPM of the motor. The motor has a positive and a negative lead, and is fitted with a custom-designed encoder made by Joseph V, which has been 3D printed. It fits on the top gear of the motor shaft and makes it easier to interrupt the brake beam setup. As the motor requires a high amount of current to run properly, an amplification circuit is required. In this case, that is done with a Darlington pair of 3904 NPN BJT transistors. Transistors amplify current as it passes through them, providing a current gain. By connecting the emitter pin of the first transistor to the base of the second, the current gain values of the two transistors multiply, meaning the current flowing through them is much higher than the current from the potentiometer connected to the base of the first transistor. The potentiometer can also control the speed of the motor. The IR brake beam setup features an IR emitter and IR receiver, or photodiode. The photodiode allows the current to flow across it based on the amount of IR light shining on it. This means, paired with a resistor, it can be used as a voltage divider. When an object blocks the IR light coming from the emitter, the voltage at the reference point decreases. The LM358 operational amplifier is used as a comparator. The positive input of the comparator is connected to the positive lead of the receiver diode. The negative input is connected to a potentiometer's C-leg, wired as a voltage divider. This provides the ability to have an adjustable voltage to tune the brake beam's sensitivity with. When an object passes through the brake beam, the voltage on the positive input of the comparator drops below the voltage on the negative one. Thus, the output goes low. Every time a tooth of the encoder passes through the brake beam, it triggers it, and the comparator's output goes low. This means that every single rotation of the motor, the beam is tripped 8 times, once for each tooth. This is compensated for in the code running on the microcontroller. The OLED display is used as a way to show a reference of how much power is given to the motor based on the potentiometer's position, as well as what the RPM of the motor is. The code for this project calculates the RPM of the motor and presents it to the user via the OLED display. It is discussed in detail in the project report.